Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem count number containing 4. So basically, we'll be given a number n and we have to return the total count of the digits that are 4 from the number 1 till the number n. Let's take some examples. So let us say if the n value is given to us as 9. If the n is given as 9, then only one number is there from 1 to 9 that has the digit 4. So the count will be finally 1 only, because 4 is occurring only one time as a digit from 1 to 9. Now when you talk about the number, let's say 14. So if the number is 14, so you have to check that from 1 to 14, how many total digits are there that are 4. So for example, if you'll observe, so 4 does have a digit 4 and 14 also does have a digit 4, right? So that is why the answer will be basically 2 here. So that's why you can see that the answer is 2. Now let's take one more test case. Let us say that if the n value was 45. If the n value is 45, in such a scenario, what numbers will be there from 1 to 45 which have the digit as 4? So basically, if you will see here, 4 will be there, then 14 is going to be there, then after 4, 14 will have 24, okay, then we'll have 34, okay, then we'll have 40, then we also have got 41, 42, 43, let's write this clearly. So yeah, we have got 41, 42, then we have got 43, and we have got 44 as well as 45. Now if you'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically you can see here that there are 10 numbers that are there, like 1, 2, 3, 4, 5, 6, 7, 8, 9 and then 10. So for 45 the answer would be 10, because like you have to return the total number of numbers that are containing the digit as 4 here. So you can see that for 45, from 1 to 45, there are how many numbers in total? There are 10 numbers in total. So how can we do this? One of the easier way of doing this is that we can iterate for all the numbers, and then we can check the digit of a particular number, that if it has the digit 4, then we'll count it, otherwise we'll not count it. But that will take a lot of time. Instead, let's discuss about that logic as well. So basically what we can do is, let's say if I had to generate, so maybe I can mark my answer initially as 0. Then what we can do here is, we can say that we can iterate from 1 till I is less than equal to n, then I plus plus. Now we can do what? We can say that we'll have a temporary variable storing the ith element, and we'll count, like we'll check whether the current ith element, it has a digit 0 or not. So we'll check temp is greater than 0, okay. Then we'll do what? We'll say that digit is equal to what? Is equal to temp modulo with 10, okay. If the digit is equal to 4, in such a scenario we can say that we'll increase our answer, and then we can break away from this loop, okay. Otherwise, if that is not so, then we'll do what? Temp is equal to temp divided by 10 here, right? And then ultimately once this is done, then we can return our answer here. So for all the numbers, we'll iterate through the digits, and if the digit is 4, then we are going to increase our answer. Let's try and run this and check what will happen here. Okay, you can see that for 45 it is giving the answer as 10. Now let's submit this code to check if it is getting accepted or not. Okay, so you can clearly see that it got passed. It is passing all the test cases. What I've done here is, we are generating all the numbers from 1 to n using the for loop, first for loop. Then for the ith number, I am checking that I'm iterating through all the digits of the current ith number by storing it in a temp variable. And if it has got a digit 4, when I'll keep on iterating through the digits of the ith number, if any digit is 4, then I'll increase the answer and I'll break away from this number. I'll move to the next number. Otherwise, if this ith number does not have a digit 4, then we'll not count it. Okay. So what is the time complexity of this code? If you'll see, we are running the first loop order of n time, right? So what we are doing is, we are running the first loop order of n time because we are generating the numbers from 1 to n. Then after that, the internal while loop that is running, it is always dividing the current number by 10. So since the division is being done by 10, so the complexity of the while loop is log of n to the base 10. So basically you can say that the overall complexity is n log n. Why it is basically n log n? The reason that it is n log n is because, first of all, for any number, if you want to check how many digits it has, so that will take log of n time. And if you want to check for n numbers in total, so that will be n log n complexity. So right now the complexity is n log n. Can we make it better? Yes, what we can do is, we can apply linear DP approach and we can solve it easily. Like what I can do here is, I can basically say that we can take a DP array of n plus 1 size, and this DP array is going to do what? This DP array that we are going to declare, initially it will be having the values as false. Okay, so initially DP of 1, DP of 2 up till DP of n will mark as false. Now how does that help? So basically, suppose that if I am at the ith number, if the last digit of the number that I am at, if it is 10, or the number divide by 10, if it has a digit, if it has a digit 4, then we'll say that we'll increase our count. Now what does this mean? So let us say that when we'll start, first of all, so obviously for one, if n is given as 45, suppose, okay, then what will happen here? Let's understand. So basically, initially the answer is going to be nothing but 0. Now what will happen here is, if you have got 45, so if you have got 45, so you will start from 1. 1 will not be 1 does not have the digit 4, 2 does not have, 3 does not have, 4. When you talk about 4, so for 4 the last digit is 10, so you'll increase the counter. So for 4 the last digit is 10, so you'll increase the counter, you will mark it as 1, okay, and you will mark the DP of 4 as what? True, indicating that 4 does have a digit 4, right? Then after that, the next number that you will be at is what? Similarly, when you will keep on moving, so 10, 11, 12, all these numbers will not have the digit 4. Then after that, when you will move to the number 14, okay, when your number will be 14, let's say I will be 14. In that case, if you will check, so the last digit of this of the number, that is for 14, you will check the last digit. For every number, you will check the last digit. Now this guy is 4, so you will again increase the counter, so answer will become 2, and then you will mark what? You will mark the DP of 14 as true. Okay. Now after this, what will happen here is, guys, once this part is done, so after 14, the next number will be 24. For 24 also, the last digit is 4, so you'll mark it as true, and you will increase the counter. So now what will happen? The answer will increase to 3. Now the next number will be 34. Okay, because 34 also has the last digit as 4, so it will also increase the counter. Answer will become 4, and then DP of 34 will become what? It will become nothing but true here. Okay. Then after that, what's the next number that you will get? After that, when you will come across the number that is 40. Okay, when you come across the number as 40 later on, what is going to happen? When you will come across 40, so for 40, what is the last digit? For 40, if you will see, so basically this digit is 0. Okay, so the last digit is 0. But what is 40 divided by 10? If I is equal to 40, so for last digit is 0. But 40 divided by 10 is how much? 40 divided by 10 is 4. So this means that if I divide this number by 10, so it is 4, and the DP of 4 is what? DP of 4 is true, indicating that it this number does have a digit 4. So I'll increase the counter, it will become 5 now. Okay, then we'll be at which particular number? After this, let's just scroll up and check if I have missed any numbers. Hopefully not. Okay, now after this we'll be at 41 also. Now when we'll be at 41, so for 41 the last digit is 1, which is not 4. But when you divide 41 by 4, it will give you 4, and DP of 4 is true, indicating that it has the digit 4. So you'll increase the count, it will become 6. For 42 also, when you will do 42 divided by 10, DP of 4 is true. So you will mark, you'll increase the answer, it will become 7. Now when you will be at 43, 43 divided by 10 is also going to give you the answer. So because 43 divided by 10 is 4, so it will be true. So you'll increase the answer, it will become 8. Now when you'll be at 44, 44 has the last digit as 4, so answer will be 9. Now when you're at 45, so last digit of 45 is 5, so that does not increase your answer. But if you do 45 divided by 4, divide by 10, that will be 4, and DP of 4 is true. So that's why you'll increase the answer and it will become 10. So this is how we can do it very easily. So let me write this code. So basically this is a DP approach which we are applying here. So what we need to do here is, let's just increase the font and see how we can code it. So first of all, what we need to do here is, we need to declare a Boolean array. So let's say we need to declare a Boolean array, okay, a DP array, and we'll have the size as n plus 1, and initially we'll mark all the values as what? We'll mark all the values as false here. Now after that, what we are going to do here is, we are going to say that if the I mod 10, if it's equal to 0, if the last digit is 0, or if the DP of I, that is the current number, divide by 4, okay, if it is divide by 10. So if the last digit or the if the last digit of the number, that is DP of that is I modulus 10 is equal to 0, or if the DP of I divide by 10. So basically removing the if the number that is divided by 10, if the number current number divide by 10, if it is returning true, if it is giving me a true, then this means that this particular number is derived from number divided by 10 only overall. So if the number divided by 10, I divided by 10 has a digit 4, then this number also has a digit 4. So you'll increase the answer and you'll mark the DP of I as true as well. So this is how you can check optimally, and at the very end we can return our answer here. That is the counter. Now let's try and compile this. So you can see that we are doing it in order of n time because we are just iterating linearly. Okay, so yes, I guess my output is not correct. Okay, so there's one thing that I should, okay, so I should check that if the I modulus 10 is equal to 4, if the last digit is 4 or the DP of I by 10 is true. So yeah, now let's compile it. So I just did a typing mistake. I should write I mod 10 equal to 4 here. Okay, if the last digit of the number is 4 or if the current number divided by 10, if it is true, then this current number also has the digit 4. Okay, so now let's submit this and it would get accepted as well. Okay, so yeah, you can see that now this particular problem is getting accepted. Now the time complexity for this approach would be how much? It would be order of n in terms of time complexity, and since I'm taking extra space as well for declaring the Boolean array, so the space complexity will be order of n. I hope you have understood this problem. Please make sure to comment understood if you like this approach. Thank you for watching this video.